Excited too. It's really fun.
Once you wrap up, closes. Go to forward reading or something. Those are my office.
What are you looking at?
I will knowledge.
Okay, guys, we're gonna go ahead and get off here.
Understand tribal knowledge.
Feel free to keep eating your pizza, and we'll have so much time to chat after, as long as Casey lets us hang out. Thank you so much for coming to the MLOps meetup, where we talk about everything. It's pretty much an AI meetup at this point. Like, that's all we talk about is AI. When have we actually talked about MLOps in the past 3 years?
Talk about feature stores.
Talk about feature stores? No.
What's the difference between a feature store and a semantic model?
That's actually a good talk on its own, yeah.
Okay. I don't know. If this is your first time here, welcome. This meetup is one of the many meetups sponsored by Forge Slack. So we have a Slack group. You can just go to our website, forgeutah.tech. Join the Slack group. We have some great channels. If you're into the nitty gritty, there's the machine learning channel. If you just want to talk about every new model that gets released every 3 days, there's the All Things AI channel. That's pretty much all I see anymore. It's just new model released. In that channel, if you're an AI skeptic, there's the anti-AI channel where we post all of the things that OpenClaw has done wrong in the past 3 days. It's fun. It's fun. We have a jobs channel if you're looking for work. We have a jobs wanted channel. And yeah, that's all I have for announcements. We do not have a speaker for this meetup next month. If you're interested in talking about anything from data science to OpenClaw, I guess that is like the other end of data science, right? Come find me or Chris, and we'll get you set up to speak. But yeah, we meet here every week, and that's all I got.
What did you say the website was?
ForgeUtah.tech. Oh, Jared represents Weave, so I'm gonna let him talk about who he's hiring.
Just say I am hiring. Welcome to Weave. Glad you guys are here tonight. We are hiring for our machine learning team. You guys are probably here because you like this kind of stuff. We have a number of different roles, just back-end, front-end roles as well. Come check us out. You can find me on Forge Slack as well.
Cool. With that, we'll turn time over to Kyle. He came from the very far away place of Boulder, right?
That's correct, yeah.
Very far away from Boulder. He says we have more snow than they do, and I was surprised because we don't have any snow. But yeah, Kyle came here. He told me about his talk a few months ago, and he kept talking about what he want to talk about. I was like, yeah, that's a better fit for the AI meetup. Sorry, you don't get to talk at the data engineering meetup. We're going to stick you with the cool crowd. The data engineering meetup's tomorrow, by the way, because I messed up the schedule. So I get to do 2 this week. But yeah, Kyle's got some really cool stuff to talk about. We'll turn the time over to him. Let's give him a round of applause.
Thank you so much. It's great to be here. Can everybody hear me okay? I'm not great at speaking super loud.
Yeah.
Yes? No? More volume? Okay, I'll do my best. I got water, so I'll keep it on hand. Yeah, so I'm from Boulder, Colorado. Well, I live in Boulder, Colorado now. I originally grew up in Wisconsin. I went to the University of Wisconsin, got my PhD there in computer architecture, and then actually spent 17 years at Google. So I've been out of Google for almost a year. I think my anniversary, my ex-Google anniversary probably was up maybe about a week ago. And when I left Google, I started building what we're calling credible data. At Google, I did a bunch of different things. I worked on high-performance distributed systems, built a lot of the core building blocks of BigQuery, did a little bit in early venture capital at Google, ads research, machine learning. In the last 4 years, I was working on Looker, and it really was my experience on Looker that's really shaped what we were building outside of Google at Credible. With that said, I got a couple questions. I just want to get an idea of like the crowd, the background, the expertise and interests. How many people here are familiar with context engineering? Beautiful. How many people here are familiar with semantic data models?
Oh, me.
Oh, great. That's great. That's awesome. What about Looker and LookML? Okay. What about Malloy?
You told me about that on a video
All right,
call.
all right, okay. All right, so we're going to cover pretty much all of these things. That's going to be, the entire talk. I've got about, 8 introductory slides, and then I'm going to jump into really demos. I'm hoping it'll be really kind of like a live discussion, like as I'm demoing stuff. If people have questions about what I'm going through, if I'm going to stop me and let's talk about it. I'm going to cover a lot pretty quickly. So if for any reason, like we're not able to get through everything during the talk or during the demo, I'm always happy to connect offline and spend some more time on it. These are things that I am truly passionate about, so we'll talk as long as you'd like to. Okay, I'll jump in. So engineering meaning. I have to admit, like this whole thing around engineering meaning, this is something that a PR firm helped me with. Like I was telling people about semantic models, you should buy my semantic models. And it turned out like the whole industry in the last 6 months has been saying the exact same thing. And so when I hired somebody to help me with communications and comms and messaging, it really helped me kind of, find words like meaning, right? Which in effect have the exact same definition as semantics, but you go a little deeper than what you hear from, Snowflake and Databricks and every other data vendor that's out there these days. And for what it's worth, at this point in my career, this idea of engineering meaning, it actually has quite a bit of significance. In fact, Joe and I were just having a coffee at Starbucks, and we were talking just about, when you've trained to be a professional engineer for so long, and all of those things that you've learned are quickly being commoditized around you, and where do you find meaning? Okay, so really quickly, LLMs. This is all just really background information so that I can jump into the demos. Really incredible at inference, right? Huge training corpus. They can tell you all kinds of things about the general knowledge in the world, but they typically have no context at all, right? And the other issue is that when you give them context, they have, like a human being, like a short attention span, right? You need to really make sure that you are preparing them with the right context for what you're about to ask them to do. They typically reason over tokens, not tabular data, right? And tokens typically represent natural language concepts and terms. There's no implicit institutional knowledge inside of an LLM. When you do not give them the right context, they will just make it up, they'll hallucinate it, right? When you give them too much context, like I said, they lose their attention and they tend to focus on the wrong thing. So what the typical flow is, when you think about, building kind of agentic AI types of experiences is, you prompt, you take some tool responses, you get the text, and then, to get anything that's reliable, you really need to make sure that the context that you've delivered, including all of this, is the exact right thing that the LLM can then make an inference based on. And this is roughly what they call context engineering. So this is a very simple slide, just to kind of distill it down. And these are basically steps I'm going to walk through, but in the context of data. So capturing context offline, taking that context and then predicting like what part of that context is relevant to the thing that you want to do at runtime. I still think of this as engineering, right? So very similar to ML engineering. Once you've got a prediction, you need to figure out how to characterize what's good and bad about that prediction and be able to evaluate that and to optimize that. And if you do that all well, you can inject the right context into an LLM and have incredible token efficiency and get the LLM to behave predictably the way that you want, right? So that's the basic, 40,000 foot view of like what LLMs are doing, where the gaps are, and what this whole idea of context engineering is. And in the rest of this talk, I'm just going to apply those concepts to data. Any questions? Anybody want to debate anything that I just said? I try to keep it as high as possible, as low as possible, so it's not debatable, but happy to debate. Yes?
So, if I'm not wrong, predict relevance at runtime, it's sort of like attention at a different stage, isn't it? I mean, it's like what you're doing when you're tokenizing is figuring out where to put your attention.
Totally.
Okay.
Totally. I would say, if you frame it that way, the difference between that and what I'm describing is, like when you want to deliver context, is that attention is typically trained on like a general public corpus of information. Right? The prediction here is almost like saying, you know, in this specific domain, under these specific constraints, you actually want to optimize what the LLM should pay attention to. And we're going to do that by injecting that separately as context into
I'm
the
sure you're going to get into how you do the
Yes. But it's an interesting observation. Like, yeah, the way that I frame this, I see like, yes, you know, LLMs also have this idea of attention and should be, in a perfect world, should be able to always identify, you know, what is the right bit of information in its window. But I think everyone is seeing, and you know, a lot of people have proven like they're not that great at that. Okay, so let's talk about context in data, in enterprise data. So this is like a typical question or intuition that like a stakeholder in enterprise might have. Like, why are in-store sales of winter jackets down in the Northeast this quarter, despite strong online demand, right? And this is the type of question that if they go to a data analyst, that data analyst in their business has the context about what these concepts mean inside of that business and how they relate to the data that that business has. And often, you know, if you ever sat down, it's incredible actually, if you just watch like data analyst UXR, like what, you know, a UXR person, what do you do? Like, what is your job? How does that work, right? It turns out that the majority of what that data analyst is doing is actually just disambiguating what their stakeholder is asking them, right? Even after that data analyst has worked with that person for years, right? You know, when you say, you know, this quarter, is it like the last trailing month, or is it actually Q1, right? Northeast, again, you know, if they're part of the business, they know what the Northeast territory is, but if they're new to the business, right, they might need like distinction in exactly what those concepts mean. So this is all the context that you'll typically have inside of an organization. And like I said, with you know, in a typical data analyst workflow, like it's this back and forth. It's a very human process of going and disambiguating what the stakeholder wants and translating it into like meaning with respect to data. And so these concepts are not simple, right? And the meaning is often not obvious to anyone involved. It really is embodied in the institutional knowledge. So that's one part of the context that's going to be missing when you ask an LLM to do some type of data enterprise type of use case. It's not going to have that business meaning. The second part is the operational data that comes into an enterprise also has all kind of nuance and context related to it, right? What is the, you know, for you, if you're, you know, working on retail systems, for example, you have 5 different point of sales terminals, right? Each one has their own data format, right? So what each one of those formats is, what each field means, what each code means, requires additional context and additional information that an LLM is likely not going to have been trained on, right? So this is other types of context that you need to bring, you know, to the LLM for it to be able to answer or do an analysis that I presented a couple slides ago. And what we see is that often this context that we're talking about that goes into this data engineering process to get the data from its raw form into something that looks sort of like the business, it's something that's evolved over years, sometimes decades, and nobody in the business even knows anymore, right? It's kind of encoded in pipelines and other logic, you know, distributed throughout the business. But, you know, if you go and you ask like the senior architect, hey, we want to rebuild your pipeline. Can you tell me what these things mean? We often have them go to Claude Code and point them at the pipeline and come back with a diagram with, you know, right? So all of this stuff, like all of this context is kind of right now distributed both across, you know, business, people that understand the business, non-technical people, as well as engineers, but nobody, right, has all of this kind of on hand and in a format that can be delivered to an LLM. Yes.
So just a really clear example, I worked at a university and the entire data warehouse was in terms, but everyone talked in semesters. When you talk about how many semesters a student is there, and there is no join, there was never one written. It was just, we all knew that you just do that translation, and there is no way to get your AI to see what just humans know. One translates to the other in this kind of format.
So this is the challenge. When working with enterprise data, this is exactly the challenge. Is like, it's kind of been engineered, it's happened, it's encoded in the system, but not in a way that any one human being or the AI can really see and understand. So that's what we're trying to solve. I just want to call out what kind of the alternative is, and I'm sure you've seen like all kinds of blog posts and people talking about, oh look, I connected an agent to my BigQuery instance via MCP, right? And the agents the AI does actually an incredible job of creating like a data story. But often, if you really dig into what it's doing, it doesn't know the correct joins. It doesn't know the canonical definitions of measurements. It doesn't know some of the semantics, some of the nuanced semantics around how to do aggregations across join relationships, for example. And it ends up with something that is executable. It produces a believable result, but often the answer is wrong, right? Going and digging down and being able to prove whether or not the answer is right or wrong requires a ton of expertise and skill unto itself. Okay, so that is basically kind of the motivation and background for semantic data modeling, particularly in this AI era, when computers need to be able to discover all of this context and information, and then be able to use it to do high quality analysis. All right, so what is a semantic model? Like I said, semantic and meaning, they basically are the same thing. So basically a semantic model is just defining what data means, right? And I want to emphasize, there's really, historically I would say the semantic model has really been the interface that like a business analyst, like a less technical user would use to access the data and be able to use consistent definitions of things and do consistent analysis across the business. But for what it's worth, when I think about a semantic data model, I actually think it's deeper than that. I think it goes into what people typically would call transformation and materialization. I don't personally make a distinction between the two because I see it's like it's an implementation detail less than the intent and the function that you're trying to perform with the data. When I think about a semantic model, I think it has an interface to the upstream experiences. That interface typically consists of measures, like what is the correct definition of this metric, this thing that people want to optimize typically in the business. It has dimensions, different axes upon which you can look at those measures. Dimension values are also a really important part of what I'm going to call a semantic model, but I think a lot of people would typically ignore those. So something like the Northeast, right? That is like a dimension group, or a dimension value, right? That is something that people will use in natural language, and you need to be able to filter but is not necessarily in the metadata itself. It's actually data values. It often includes documentation or institutional knowledge. And this documentation is often distributed across all kinds of bespoke systems, from catalogs to PDFs to comments and scripts. And lastly, it has governance constraints, right? Who can access this? How can they access this? What are the operations that they can perform on that type of thing? And I would say all of this, when you standardize all of this, it also provides basically a layer of governance. You're effectively governing the definition of what these things are, so that when anyone uses these concepts, they use them consistently. They use them in a governed manner. The inside, yes.
I'm just curious, what's the relationship between the semantic model you mentioned to the embeddings we save in the MetaDB? So is there any correlation between those two?
Like semantic search versus semantic model?
I'm just trying to understand the semantic model versus the embeddings, right? So what's, yeah.
Yes.
Anything related to each other or nothing to do with each other? Just trying to understand your concept. Yeah.
So like I mentioned, so semantic is basically meaning, right? So here is a definition, where we are defining the meaning of something, right? Later in this talk, we'll talk about how do we retrieve things that have similar meanings, and that's where semantic search, comes in. So the word is consistent, like we use it consistently across both, but one is the encoding of meaning, the other is going to be the retrieval of meaning at the right time in the right context.
So that's the later phase. This is a.
Yes. But I would say that typically when people use these two terms, semantic search and semantic models, they're in completely different domains, and there's very little overlap.
And then you have semantics, ontologies, and all that other fun stuff.
Yep.
Super fun.
Yes.
Maybe this is too early to ask the question, but so is this model in a vector database? Is it embedded in a vector database, or how is it representation is what
Yes.
I want to know about?
This is where the demo is going to really shine.
Okay.
So we are going to encode this meaning in a representation that's very intuitive for a human to understand. Once we've encoded that meaning, we will push it to our system where we will index it in a vector database, so that when an AI wants to go and understand it, it can use natural language to retrieve the concepts in the model that are related
Yeah,
to.
sorry, I'm kind of a bottom-up guy. I have to kind of know where.
I'm a bottoms-up guy, dude. Yeah, so like this is a very engineering-driven talk. So like I'm trying to just kind of frame what we're trying to do, and then we're gonna jump into Cursor, and we're gonna build this stuff. And I'll go slowly so that you can stop and ask questions. Like right now, I realize it's kind of abstract, but we'll get down to the nuts and bolts really quickly. Okay. Then, I do want to emphasize, there's two parts to this though, right? There is the interface that we're defining of what data should look like and how a business can reason about it, and that's the left-hand side. Now, there's also the transformation process, right? We have to go from raw data to that interface, right? And that involves things like joining data, transforming data, doing computation, right, in order to get the data into the right shape, parsing JSON, handling edge cases, dealing with nulls, cleaning data, right? And I actually, like I said, I actually consider these things as the same problem, right? Because ultimately it is, you're going from raw data, you're going up to a representation that you can drive a data consumption experience off of, right? And, from a tooling and efficiency standpoint, like treating those things as the same problem, I actually think is going to lead to like some massive unlocks with AI. Just to kind of make this a little more grounded, like when you look at the way this whole process is driven today, it's at an incredibly low level imperative, like, right? It is managing storage, writing SQL statements to go from one format to another format, storing it, going to another format, storing it, going to another format, storing it. In many ways, it reminds me of like going back to my graduate degree in computer architecture, where I was like moving bits and pieces through memory locations and through register files, right? If you can imagine a much higher level of abstraction where you can logically describe the shape of the data that it's currently in and the shape that you want it to be in, you can imagine a brand new type of runtime system that's able to, optimize that and handle a lot of the complexity that humans have to deal with by hand, right? Do that in a much more automated fashion and really lean on AI to drive like a kind of a feedback loop and optimization capability. So this is one of the reasons why I talk about this at this high level. Although in the literature and mostly in the field, you'll see people refer to the transformation materialization separate from the semantic modeling. Okay, all right, these are gonna be demos. I just wanna talk through really quickly what I'm gonna demo, and I can come back to these slides after I demo. But what I'm gonna show you is I'm gonna build a semantic model. I'm gonna do it with a modeling agent. It suggests measures and dimensions and join relationships, generates documentation, and aligns on canonical definitions. Now, like I said, if the agent doesn't have enough context, it will hallucinate all of these things, right? And it's incredibly important that like when you're talking about how a business like measures and analyzes, how well it's doing, it's incredibly important that that measurement, that metric comes from like the business, not from an agent, right? So what you're not going to see behind the scenes is that we've actually built a ton of pipelines that when we connect to your data, we're able to look at schema, we're able to look at SQL logs. If you've got LookML semantic models, we're able to ingest those as well. And those backline pipelines basically try to grab all the artifacts that we can find about what this data means from the existing structure of the data. And then we basically build We infer semantic models offline based on those artifacts, and then we index them, make them accessible to the agent to ground all of these suggestions. Yes.
I've never seen a reference here on ORM. Would it be better to extract from an ORM or just strictly relational?
This is a great question. Like, so ORM is a term that's used like when you're doing transactional processing. Semantic model is like pretty similar like concept, but for analytical processing, right? And this is an important distinction, right? So really everything that I'm talking about is like the aggregation of data, right? You're doing analysis of the data. It's not like you are, updating records or reading individual records, which would be much more transactional. But ORM and
We'll talk later on that one.
and there are people that believe like these two concepts should actually be one. But in today's world, in today's tech stack, they really are two separate. Like they're kind of two separate.
Well, they are separate. There's a reason they're separate, but go ahead.
I'm gonna go through this really quickly. Dimension values, like I said, are important. I think I already kind of gave enough of an example of that, but you'll see like in this process, we'll identify things that are categorical, things that people refer to when they ask questions in natural language. And I'll show you how we'll handle those. Something like SKU 84729 is a perfect example. Like that's could be completely bespoke to that business. An LLM would have never seen that SKU ever. And so if that's something that somebody will refer to in the business, you have to give the LLM that context. And then I already mentioned this as well. So once we build a model, we encode it, we publish that to our system, we index that or basically embed it inside of a vector database. And then that's what we use to basically allow agents or LLMs to interrogate the semantic model using natural language. And the one thing I really want to emphasize here is this bottom bar is that we do not dump the semantic model into an LLM's context. We retrieve the context selectively. So pretty much everyone I see, even companies that are in the semantic modeling space, they just assume that you can take, like in some of these cases, very, very large semantic models, dump them into the context window, and the semantic model, or I'm sorry, the LLM is going to be able to find the right entities for the thing that somebody's asking. We firmly believe that's wrong. And I think as we get into the demo, and in particular into the evaluation, hopefully people will recognize, if you can decompose this problem, well, like it becomes more efficient, and it becomes it's easier to evaluate and optimize. Okay, so I'm going to pause there and jump into the demo. All right, and this is let me try to zoom in a bit. Okay, so what we are looking at here, this is Claude, okay? You see down at the left-hand corner, there is a little box here that says credible. Demo is the organization, project is Start, and there's connections in here. So basically what we've done is we've installed a VS Code extension that is able to connect to our platform. And once it's able to connect to our platform, it can see basically all the databases that we've already configured in the platform, and it gets access to a set of MCP tools. Sorry, let me open this up. But you can see here, there are 4 MCP tools that are accessible through the login, execute query, search data for modeling, which looks at schemas, search entities, which looks at joins, dimensions, and measures, and then Malloy documentation. One other thing that I'll call out is that we try to be as like stock cursor Claude as possible. So when we install our extension, we actually install a bunch of rules about how to be a data modeler for Claude, as well as skill sets and rules files, right? So this all gets dumped as soon as you install the extension and set up this workspace, right? So that is basically, again, that's the architecture. It's stock Claude with some skills files that we've dumped, as well as like access to a couple of MCP tools. All right. With that said, let me make sure that Claude's alive. Our cursor's alive. Please let me know what data is available to model. Yeah, And I don't know, I've heard that if you're really nice to the LLMs, or if you swear at them, you get better results. Like, how many people are nice or how many people are swearing? I tend to be nice. I grew up in Wisconsin, so it'd be hard for me to be mean to the LLMs. Okay, so what you see, that just happened, basically, when I asked what data was available, Cursor went, used that, the data modeling tool, search data for modeling, right? This is the tool that we provided. Came back with, we have a handful of like public data sets that we've uploaded. And basically came back, here are the data sets that are available, and it has some schema information. What's that?
And those are BigQuery public data sets.
Yes, they are. Some of them are actually Bird SQL and BigQuery.
Yeah.
Yeah, but yes, you got
They're
it.
very familiar.
Yes. All right. So okay. So everything's connected. Now let's do some modeling. Let's model the e-commerce data. All right. Now I'm going to do play-by-play in case people can't see what's happening. So of course it does some thinking, and then it starts. It's going to discover the e-commerce schema, all four. That's its first plan. First step in the plan. And then it goes and it runs basically the search data for modeling. So that's pulling schema down. All right. Now that it's got the schema, it's going to call back into our platform and search for entities. These are the measures and dimensions and joins that we discovered when we were processing SQL logs and schema offline, right? Now it's going through and it's basically figuring out, oh, this looks like a classic star schema, right? And yes, it is. In some cases, it'll suggest other types of data models. You saw that it went and it talked about join one versus join many relationships. This is also super important. There's something that was invented by the Looker people called symmetric aggregates, and it requires you to understand the cardinality of your join relationship in order to count things correctly. So it was recommended, you looked at the cardinality, it's executing some queries just to understand the shape of the data. Again, to test like cardinality assumptions. And then it's going to think for a while. Sometimes it thinks long. Sometimes I feel like I get like, the really quick cursor or sometimes I get really slow. Let's assume that's going to think a while. Anybody got a good joke they want to share?
Sorry, what's the name of the extension again?
So the name of the extension is credible, right? So if you go to Cursor or like the VS Code marketplace and you just search for credible, you'll find it. Okay. So now it looks like it did, it's thinking again. All right, so while it is thinking, I'm going to talk a little bit about Malloy, the language, the semantic modeling language it's going to generate. So Malloy was built by a guy named Lloyd Tabb. Lloyd is the founder of Looker. He has been building semantic modeling languages for over 20 years. And in many ways, Malloy is intended to be basically his masterpiece, right? So after creating Looker, it was very commercially successful. He wanted to create a semantic modeling language that was open source and just much more widely adopted in LookML. So it's MIT license. He wanted it to be people to be able to develop it like however they work. So he adopted VS Code as the main way to develop it. It is a true language. It has a language server. It has all the things and niceties that you'd expect from a modeling language, right? Which doesn't sound like a lot unto itself, except when you realize that most of the people that are doing this type of work are doing it in SQL. Right, which is a 50-year-old language, doesn't have simple things like named variables, doesn't have imports, doesn't have encapsulation, doesn't have a lot of the basic stuff, right? Okay, so it looks like it's got done thinking. It went through its whole process of building this, all of its steps to build this model. It went and created a publisher.json, which is the package manifest that we use. It ran some queries against the model. And then, or the data, and then basically came up with this suggestion for them. And the suggestion is, there's 4 tables. These are what the join relationships look like. And then it actually comes up with a couple of observations that these are things to watch out for. It's basically notifying me that these are things that could create problems in this model, and would ask me to validate that, yes, these are the correct column names, that they've been documented correctly. And it even goes on to suggest you want to create some views of this data, right? So I'm going to say go ahead and keep all on this, and basically show you the model that it created. Sorry, hit the wrong button. All right, so this is Malloy. Is this big enough for folks to see?
I think it's good.
Okay. I'll try to shrink a little bit. Can't see everything. Okay. So what you see here, there are actually multiple tables. I'm going to focus primarily on the bottom one, right? Because it did say it's going to build a star schema. And so that bottom table would effectively act like the fact table on the star schema. But you can see that there are a number of tables here, from products to users, right? And each one of these tables has been wrapped and wrapped in a source, and we've added dimensions, measures, joint relationships, primary keys, right? Automatic to this data. Right? So let me go to the bottom. Now I'm going to talk through what the fact table in this table looks like in the way. So the first thing is the fact table, it chose order items, which is great for an e-commerce data set. And then it goes actually, and it has this include section. And what this is doing, this is actually something, this is a pattern that we have adopted that basically says out of all of those columns in this table, these are the ones that you should include publicly in the interface of this model, right? So often you'll see, you'll get tables that have hundreds of columns and like only 10 of them are things that you would ever want like an AI agent to be able to do analysis on, right? So basically what this block does is basically hides, the 100 or so columns that are meaningless, the LLM should never see, and then really promotes the ones that are relevant to be used, and adds documentation for each one of those columns. Yes, was there a question?
Yeah, just wondering how you figure out the definition of each thing there. Like, is because of the comments in the tables or in the data, or how do you figure out that that is the unique order identifier?
So it's a combination of a number of things, right? So one, this data set, we had both some SQL logs. For the Bird SQL data sets, I'm not sure if this one is in Bird SQL. We have SQL logs, right? So we have LLMs that actually run over the SQL logs and see what columns are being used, right? And then we look at how they're being used, right? So we can look at things like an aggregate and a select clause, and that typically is a measure, right? So we'll pull that out and we'll say, this looks like a measure that's being used in the business. If it's in the group by, we'll say, that's a dimension that people will look at this data on. If it's used in a where clause, right? That's a filter value, right? So our offline basically goes and looks at all like SQL and schema logs, and then we'll go and populate this index, right? That you saw Cursor call into, right? But then ultimately Cursor makes the final decision. It looked at the schema, it looked at what we think the data model should be, and then basically is bringing those two together to recommend what you're seeing here in this model. One of the other things that we do support is, for example, we've got one customer where they gave us a 200-page PDF where not only did they give us the columns, but they gave us like a couple sentences of what each column means. And in those cases, we'll also attach that metadata to our index semantic model so that we can actually use the language that the business uses in the documentation page in the model.
And does it help to have that metadata in the database, like the definition of each column, tables, things like that? Does it help this?
Does it help the AI that uses this model, or does it help?
Yeah, to build this semantic layer that you maintain.
Yes, this is what I'm gonna show you. This is all the context, right? Remember when I talked about what our goal is to go and capture all this context that's floating around a business, both what the terms that people are using for things, the correct definitions of measures and dimensions, the data transformations that have occurred inside of a medallion architecture. We want to be able to capture all of that and then encode it succinctly in a way that's very easy to comprehend in a single language and a single model file. Yes?
I saw it scroll by earlier, the KPI cards, is that something you extracted or is that something in the database itself? KPI, no, it was in the right column. It was earlier, KPI cards is what it,
Yeah, so
is that what I think it is?
So what this is after it built this semantic model, it ran a couple queries on it, right? To just kind of smoke test it and see if it makes sense, right? So if I was a user, if I was in this business and like I just built this model, this is a way for me to be like, yes, 12.6 million seems like the right revenue. And actually, let's actually, well, does 12.6 million revenue include insurance?
So is that summary something that you did?
No, this was Claude.
No, I mean, Claude did. I don't mean, but it wasn't in the database.
That's correct.
Okay, that's
Correct.
very cool.
Yes. This whole thing, basically what I showed you on that whole right side, it is like what like a data model.
So it figured out what the KPIs are from your database.
Yeah, absolutely. I mean,
That's
it also
awesome,
knows it's
dude.
e-commerce. We also gave it like SQL
Okay.
statements, like aggregates that we saw, right? So it took a bunch of stuff into consideration, and it turns out actually it did. It did not take out the returns, right? So it came back and updated this measure to exclude canceled and returned items, right? And so basically what this thing is doing is like, this is what a semantic data modeler does. Like when I worked at Looker, like Looker would engage with the customer and they would spend like weeks working with that customer to build this model, that Cursor just built in like 20 or 30 minutes. And the process looks very similar. The reason why the process looks similar is because we've encoded like that skill set in these skills files, right? Where they come up with the first cut of the model, they run some queries, they validate some of the assumptions, right? They raise like, did you mean net revenue here versus just gross revenue, right? And we've really tried to encode, we've actually got a number of ex-Looker sales engineers on, that are advisors that have helped us basically encode that into this modeling agent.
Yeah, so that comes default within Cursor, but let's say we're using Claude Code. Can we go grab that model and throw it on top, and where would we go to get that?
So yes, this works in Cloud Code as well. So one of the beautiful things is that these are the files that basically are driving this. Here's the MCP configuration, which basically points, right? These are all standards now, right? So like this works in VS Code, this works with Cloud Code. We haven't tried Windsurf yet, it's on our list. We haven't had a customer ask for it. But yeah, this is all standardized now. So, and you'll get slightly different behavior, right? Cursor and Claude seem to be the best at this type of coding task, but the VS Code agents are pretty good. Claude Code is amazing, especially on big models. Okay, so I forgot where I was. I told you I really like talking about this stuff. Let me do one really quick thing. Let's do a quick analysis and build a notebook. Brand analysis or brand performance. Okay. Okay, and so this is going to go through and it's going to look at the model, and then it's actually going to do an analysis of the model and encode it as a Malloy notebook, which is just a set of queries. So let me go back, while that's running, let me go back and just explain a couple more things about this semantic model. I mentioned, okay, so we have a source table, we've got documentation, we've said there are some raw fields in the source table that we want to make available to our upstream agent. We've got join one relationships, right? Again, we're defining join cardinality so that we can aggregate correctly. And then we've got a number of different dimensions that are likely things that we'd want to look at, when we are querying the data. Each one of these has these documentation tags. These are not comments. These are actually annotations, right? Similar like to you have an annotation in a modern programming language that allow you to attach metadata to these different concepts in the model. And that metadata can include, basically documentation so an agent can understand what it is and how to use it. There are things like, this if you're gonna render this thing, it's a duration. You should render it as days. Currencies are also tags that we attach. And one thing that we don't have in here that I noticed, and I think this is actually a recent change that we made to our agent, is that we have a number of things that would be categorical values, right? Those dimension values that people might refer to. But we don't actually have anything that tells our service that we need to index those dimensional values and make them really accessible. So not yet. So I don't want to publish this to Credible yet. Let's add. Well, let's just say let's optimize this model for retrieval. Okay, so then what the agent is going to do is going to recognize, okay, I see that you want to use this basically for an agent upstream. And it's going to, one thing it's going to go through is it's going to go through and it's going to add these index value tags. Sorry, it's scrolled. You'll see them in just a second. It's going to add annotations to the categorical values that people might possibly refer to in natural language. And after running for a little bit, they should pop up and I can accept them. And then while it's working, I'm going to go, sorry, I'm switching. This is my typical development workflow, by the way. This is the notebook that it generated when I asked it to do just like a high-level brand performance analysis. You see, basically, it looks at which brands generate the most revenue. This is a Malloy query. One of the beautiful things about Malloy query, this gets translated to SQL. In fact, I can show you the SQL here. SQL comes out typically pretty gross compared to like something that's really clean, right? We want to group by the brand. We want to look at the net aggregate revenue. We do some filtering using a halving, right? And then order by net revenue. Pretty clean compared to SQL. A couple other queries, scorecard of different metrics associated with each brand. And when I push this to the platform, this will actually show up as like a standard dashboard. Yes?
Say they have a client or boss that really loves their spreadsheet, giant, sprawling Google sheet that everyone enters information in. Would you need to put this into BigQuery first, or can you? Well, how would you approach that sort of nightmare?
DB attach.
What?
DB attach. So one of the things that our platform does is we run DuckDB internally, right? So you can take CSVs, you can embed them in your packages, and we'll actually provide the query and the storage. But DuckDB also allows you to attach to all kinds of databases and things that aren't databases, Parquet files on S3, Google spreadsheets, right? Okay. And that actually allows us to run through this entire modeling process, on a spreadsheet. For
Yeah, they're really fast. That's cool. That's a good answer. Thank you.
All right, I'm going to switch back. And you can see it updated some docs, right, to make it clear that some of these are categorical, as well as added these index annotations, and the number of things to index. So this is like 50, this is, index all of the values. So what will happen next? I'll just run through this very quickly. I will publish this. And this is that slide that I showed you, where basically now it's going to do some CLI commands using our CLI, and it will basically push us to our platform, and our platform will go through each one of these models, each one of the annotations, and those annotations basically act like instructions, right, for what to do with this model, right? So the doc tags, we compute embeddings, we put them into our vector database. The index, we say, okay, we need to do find all the unique values, and put each one of those unique values into our database. We support things like fine-grained ACLs, so you can actually put an access control tag on here that you can only access this if you're in this group. And we are in the process of adding support for materializations, right? Like this view of the data is like a view that people are going to access frequently and should be latency sensitive. So please materialize that view. And one thing I did not, I think I sort of showed, but just so that everybody realizes, this is just a high-level representation of SQL. So ultimately, this language compiles to SQL. This is the SQL statement for this view of the data. One big difference, though, between Malloy and the semantic modeling language is that there's a clear distinction between query and the logical data structure, right? So typically in an SQL statement, it'll actually conflate them. So you get joint relationships alongside like aggregates, right? And group bys and stuff like that. Whereas in the semantic modeling analytics world, people really believe strongly that you need, like there are aspects of SQL queries that are specific to the data, right? You don't need to understand anything about what people want to do with the data. These are attributes of the data. They should be in the semantic model. They should be abstracted away from the querying portion of the SQL statement. So the queries are very high level. They're in terms that are governed, well-defined, right? And much easier to comprehend in a semantic model than if you're trying to do some of these things end-to-end. All right, it looks like everything is published now. So and this is the end of this is gonna get close to the end of my demo. I think I'm doing okay on time.
You're doing great.
Okay. Now, this is where we are gonna show, like, what do you do with this? It was really cool. I mean, it's cool. Google paid, 10 engineers, like a few years, build this language, right? Make it open source. It's a cool language. But a language by itself doesn't create impact, right? You need a runtime. You need like a solution around this, and you need a consumption experience to create that impact, to create that insight. So I'm going to switch quickly to the app. And I'm sure everybody's seen a billion data agent things on LinkedIn, all over the web. This credible agent is just a thin layer over Claude, right? The only reason we even built an app is really so that we can demo it and we can show people the types of requests and responses that we're getting from Claude, just so that it makes sense about like what is actually happening, what context is being injected into the LLM, and then what the LLM is doing with it. If I gave this demo with like I can give this exact same demo in Claude.ai, like web Claude, using our MCP tools, but then I have to like try to parse these huge JSON blobs live, and it's painful for me and it's painful for the audience. So we built this thing instead. Okay, and I'm going to ask.
Can you zoom in just a bit?
Yes, sorry. Let me ask a question that hits a couple of things. How many Ray-Ban sunglasses were sold in the summer? All right. Okay, and again, this is Claude. So we just asked it a question, now Claude's thinking. And the first thing it does is it calls get context. And I'm going to actually wait for that get context request to come back before describing what it does, because it's much easier just to visualize the results than to describe it by itself. But what you see, and this is basically, so this is an MCP tool that our system has implemented, right? And so what you see is that first thing it did is it took the text here and it isolated the data concepts, right? So how many is a count, right? A count of order items, right? Ray-Ban sunglasses, and this is where like that term, like the dimensional indexing comes in. Ray-Ban is a value in the brand dimension, right? How many were sold, right? Order status is returned is also included. And then summer, right? The order month. And for each one of these things that it returns, it will sometimes return multiple, like if it's not comfortable about, or if like our sub agent that's doing this analysis is not comfortable with just provide one answer, it'll give multiple responses. But it will also, one, provide the documentation, right, that was embedded in the model. Our LLM actually uses the context that was passed in as well as the documentation to actually provide a description to the upstream agent, in this case, like Claude, or why it chose that one, right? And then gives it a score. And it does that for each one of these different things that's returned. So that's what we really, so when we say like, we want to really break this down and really return like a high fidelity context, this is really what we mean, right? We've identified all the things that the user and the upstream agent cares about, and we've really broken it down and provide just the information necessary to answer that question. And one thing I would say, so this is one thing that Lloyd, the founder of Looker, taught me. He taught me that ultimately at the end of the day, like when you talk to a data analyst, like what their job is they try to, they have a stakeholder, they ask them a bunch of questions about a bunch of different things that could be in the data, and they ultimately just come back with the minimum cube required to answer that question, right? So basically, you've got some, you care about a measure, you've got some different dimensions and intuition about what that measure depends on. And the analyst is really just trying to find the minimum cube, right? To go back to the stakeholder that would answer their question, and then walk them through different ways that, to look at the data that's captured in that cube. That is effectively exactly what this is, right? We are basically just taking the sentence and finding the minimum cube and we're giving it to Claude to do an analysis. And after this point, you know, I'm worried that I'm gonna get disappointed, but like, Claude is able to pretty much do everything else, right? And this one actually turned out pretty easy. Let's do.
Question.
Yes.
How do you, what did it look like figuring out how much context you need to output from the side agents versus like how concise it needed to be?
So this is a great question, actually. This is actually one of the things that we are working on right now. So what I just showed you is like a classic text to SQL kind of question. And like this way of breaking down a problem is, the way that we showed you is great for answering that thing where it's got like a single answer. But like when you ask, like, for example, let's compare performance to other brands in a data set. It actually is much more open-ended. Like this is the kind of question where it's like, I don't know really what the minimum cube is for this, right? You know, it turns out actually Claude is gonna go and try to use the cube that we gave it in the past, because we already gave it a bunch of measures and dimensions upon which to look at these things. And it's gonna come back and it actually had enough in its context window already to do a decent analysis. But like, this is pretty good, but maybe we wanna dig deeper and see what other data is available. Right, and what I'm really trying to do is like prompt it to like basically call get context to try to kind of find a bigger view, different ways of different performance measures or other things that we could be looking at. And I have to admit, like these are the types of things that we're still kind of optimizing. Like we know kind of we've really focused on this problem of like making sure it always gets the right context. Now getting Claude to like ask for the right context is something that we're still somewhat figuring out. Yes.
Did you use Spacey for that entity resolution within get context, or did you roll your own? Like identifying that how many is a count entity?
Like Spacey requires like natural language processing and like engineering. We use the LLMs. No, actually, it's actually quite involved. So we do use LLMs to do the initial phrasing, and it turns out just looking at going and extracting phrases from a sentence is actually very domain dependent. Right? There's especially when you get into like acronyms that people use, like in LLM, if you just say take out the data concepts, it's not going to recognize some of those acronyms. So we have actually a prompt, a set of instructions that people can add to our system that encode domain knowledge about how to break the phrases out. Once we've broken those phrases out, we tend to do it overly conservative. So we want to get more phrases, right, than might be there. Because then we go and we hit a retriever, right, that has all those embeddings. And then we basically fetch, like, here are the different phrases, the different kind of data concepts that could be in the sentence. Here are all the things that could match. And then we actually feed it back to another LLM to basically do refinement, re-ranking, right? And then distill down which phrases are the most likely to align with what the user intended. And this is something that we've had to iterate on. Some of this stuff actually did require engineering, but Spacey is like, that more? Yeah, that's like next level. Okay. It's like when you give somebody a hammer, right? I mean, everything becomes a nail.
Yeah. You would do. That's something I would do.
Yeah.
You were
yes. Yes. I don't know. Can you arm wrestle or something to figure out?
We can start.
Okay. Yeah. Do you think who's going to be the actual user for this user interface? Do you think it's going to be the data analytics or the business user or both?
Business user. Yeah. No. So and we also kind of we kind of have used like a Looker style of like you have a data modeler persona, which is semi-technical, and for what it's worth, even that data modeler, that cursor thing that I showed you, we're actually trying to make that like all in app and does not require like an IDE, doesn't require a ton of background knowledge about like technical tools. But right now, it requires you to at least be able to understand IDE, understand how to push a package, right? These are pretty technical. In the future, I'm not sure if that would be the case. But that's what we'd call a data modeler. And then this would be like the stakeholder or data analyst experience, where they would be able to come in here and just type natural language questions. We want to do a better job of context tracking, right? So once we've returned entities to the agent, we can do a better job of tracing how that agent actually used those concepts in order to generate, for example, a dashboard like this. And we believe like that will allow people that don't have, like, that have very little data literacy, right, to get much, much deeper into their data than they've been able to in the past.
If they can generate the dashboard from here directly, so in theory, they don't need to go, they don't go to the SaaS AI UI anymore, right? So
Exactly.
this is from here, and then this has become the new UI for them.
Well, yeah, I mean, and I want to emphasize, when I say new UI, like, it's not the Credible app. This is like Claude, ChatGPT, you know, pick your enterprise element, pick where your knowledge worker is going to be working. We're going to give that thing the MCP tools so that they can analyze data like this alongside all the other tasks that they need to do during their day.
So does that chat window, is it translating it into SQL directly or into this other language?
Sorry, I kind of skipped over it. No, it's generating these Malloy queries,
Okay.
right, that then are sent to there's the execute query call. The Malloy query is sent to the semantic model. The query plus the semantic model logic, we compile it down to SQL. We run that on the database, and then, you know, we use the tags, remember those annotations, right, to know how to render it when the result
Okay,
comes.
so if you asked, if your query was something of the form, you know, give me customer satisfaction, which could be inferred by a whole bunch of other things, may not be a direct, you know, database call or something, but could you ask it something like that and it would actually figure out what it needed to?
Totally.
Could it infer it?
Yeah, and if you saw that example, there was a similar concept. I asked about performance, like brand performance, right? And it can mean tons of stuff, right? It can mean the revenue, it can mean the number of orders, it can mean.
That one seems a little more direct though, that one.
Yeah, but I mean, yes and no. But so what Claude will do, like typically, like a model will have a bunch of different ways to look at customer satisfaction. They will be lower level concepts, but usually the upstream agent will expand. Like it'll say, what's the CSAT score? What's this, right? It'll ask for a bunch of things. And then the other thing is like we're doing semantic similarity or
I'm
semantic
curious
searching.
how it makes that inference though. Like do you have is it another LLM?
There's two things, right? So Claude will naturally expand. Like if you ask for like customer satisfaction, it will use CSAT. Like it will use these terms that it knows are common ways to measure.
Claude's being the workhorse in this case.
Yes and no. So when it gives us a bunch of those terms, we then do a similarity search, right? So even though you ask for CSAT, right, there might be another way that we measure customer satisfaction, and you know it's got a documentation tag associated with it. So even though it's not exact match, not CSAT, right, we're able to say like those things are in the same location in the embedding space,
Okay.
and we'll return those as suggestions.
Is there a way for the end user to know whether or not the output is an AI hallucination? Like, is there any kind of governance? Or
So there is. So there's two parts to this, right? So we are returning facts, right? So we looked at the semantic model, and I want to emphasize one of our assumptions is we're assuming that this is like a governed model, where like an SME, a subject matter expert on these measures and dimensions, has reviewed it all, right, and approved it and said yes, this is the thing that should be served upstream. So then what we're doing is we're taking all those facts. Those facts are well typed as well, right? We're giving them to an agent or an LM, and we're letting them compose those facts in different ways, right? And if it composes them incorrectly because they're typed, we can say, you can't group by a measure, right? We actually will throw errors to Claude and correct it, like if it misuses these things. But assuming that it understands the concepts that it's composing these queries, right, the answer that comes out will be correct. And usually the description that Claude then generates to describe that thing is usually pretty accurate, right? The description I can't give 100% on because like I don't have like a formal type checking system on that. But when it composes the facts that we give it into queries, like those, like it's I can't say it's impossible for it to get something wrong, but it's very well kind of guardrailed to produce the right answer given those things as inputs. So yes.
Okay, so maybe I missed something in there, but you've got these guardrails in place, you have the LLM that the end, end user who's not technical is going to be using. How do you guarantee that that end user is getting, those guardrails are being activated under the covers versus?
So the guardrails are definitely, so this is really where I was mentioning that we want to be able to track the use of context through an analysis better, right? So like if up here we gave, up here in the get context call, we gave Claude, here are the names of like the brands, this is how you filter like sunglasses. When you think about how many, these are, these are the dimensions or measures you can use, right? So we give it those contexts, that context, and then Claude is able to compose those. Right now, this user experience is not great in terms of seeing like, okay, once you've given that context, how does it flow into the analysis? But this is one of the big things that we are working on actively right now is like, what does that user experience look like? And then how do you audit that, right? Joe and I were talking about context graphs. There was a thing that came out, context graphs were like super exciting. It really is this idea of like, how do you capture all the bits of information that go into these agentic workflows that then influence decisions, and then ideally track that decision and feed it back into like a decision optimization. This is an unsolved problem, but like
Well, especially across multimodal data, right? Not just tables, but other stuff.
Yeah. Our ambitions aren't great enough. That's what you're telling me.
Well,
we're gonna solve our little piece of the problem.
Yeah, you do that.
Okay, really quick before everybody disappears. This is probably the best insight of all of this, is that the way we have decomposed this problem around context is that we can measure it, right? And it turns out it's just a search quality. It's a really, really well understood problem. Like what I showed you, like where we took these sentences, we identified, we'll call them keywords, right? Those keywords go into a search engine, right? They find all the different web pages that are associated with those keywords. They bring all of those back, they re-rank them, and for each keyword, right, there's some suggestions of like which pages on the map, right? So this is, like we're using different algorithms, right? But the problem definition itself is effectively search quality. Which means that we can take these phrases, we can label these phrases to know how they should be chunked, right, into data concepts. And then we can go and optimize our retrieval algorithm to make sure that, actually, not even our retrieval, we optimize our semantic model, right, to make sure that it has the right metadata to retrieve the type of context that the agents and the users are asking for. And so this is really, when you look at our business, I think long-term, this is the key, is that we can take a bunch of questions that people might want to ask about a data set, and we can then go with really high confidence and really high fidelity, optimize the model to make sure that agent is always getting the right context, right? And that means that ideally, the analysis that they're doing is going to be higher quality and people can make better decisions. Yes.
I guess your engagement with clients and whatnot. I mean, obviously, maybe you start off, kind of get going, and then they provide feedback. Yeah, this area, here's some examples where it didn't do so great, and then you kind of go back and I don't know. I imagine you update context files or whatnot to kind of solve for that. I mean, is that does that iteration to kind of eventually get to the point where they're like, wow, it's really hard to find issues at this point? Is that a period of a couple months?
No, it's about weeks, right? So this is one of our bigger customers. It took us a couple weeks to do this, and I would say that we did this manually, where we were taking ground truth that they gave us in a spreadsheet. We were running that against our retriever, and then we were manually doing this. But here's where this is going, is that we are moving to a world where we capture the queries that are flowing into our APIs, and we are looking at how confident we were in when we were able to detect phrases, when we were able to match entity to those phrases, right? We basically capture all of that data in a big data set. We build a semantic model of that data, an aggregated view of what queries have high hit rates, which don't, which terms are not modeled in the data. Once we have a semantic model, We automatically access that semantic model with MCP tool. Once we have an MCP tool of like our error analysis, basically, we can feed it into cursor, right? And then very quickly, right, the machines take over, right? And this is what I was telling Joe earlier, is like, I think long-term, the only thing that this semantic model is gonna do is it's gonna be an audit log, right? These decisions were made on this version of the semantic model, and those decisions were bad. So let's go look at the semantic model and understand like what context was missing that led to bad decisions. But the whole loop will be like fully automated with the machines. Driving, evaluating, if quality's better, automatically push it.
How extensible is this to agents right now?
You like LLMs?
Yeah, if I just wanted to throw my agents like OpenClaw at.
It's all MCP tools. We have a firm belief, like all of the, like I said, again, all of those UIs I showed you, like Cursor I think is pretty durable at this point. They're doing great. Our web app, like not at all, right? Like that is really just something that we stood up to talk about it, do demos. The real power is like the MCP tools that are powering that web app, and you can plug them in to anything. Yes. Yes.
So I can tell this application is built more for as an internal tool that works specifically with Claude. So I'm just wondering if the company is like trying to sell a large data warehouse to many customers, how difficult would it be to scale this so that thousands of customers can query this at the same time? Like, do you switch out models or practices, tools, anything like that?
So this is where, so for what it's worth, if anybody wants to try this, I'm happy to set up a free account for you. You can totally run through what I did right now, right? What I did would be like a traditional IBI use case. And I really question like where business and IBI is going. Like with the, like just the power of the analysis that I showed you in Claude, right? More and more people are seeing this, more and more people are creating their own dashboard and their own tools. So that feels very, like the technology will be widely available in the next year or two. So that we really aim to make that experience as low cost as possible and really get people to be playing with these tools. Where we really think we'll be able to differentiate is the fact that we built this on a massive multi-tenant distributed system, right? And so we can go to like, let's say Fidelity, right? And we can say, hey, your clients are making really important decisions on their portfolio, right? You really need to make sure like whatever agentic thing you build has the right context, right? Really, spend a lot of time and optimize for their use cases, for their customers, and then deploy it at scale with ACLs and compliance and all of the things that are required at that for that type of customer. That's where we want to go. Yes.
Last question. You're right.
I haven't asked lots. Was there someone else? I was going to ask about I think you said there was a vector graph or a knowledge graph somewhere in there. I missed where that got.
Vector database.
Vector database, yeah.
We don't do graphs. I had a bad experience with graphs at Google.
Really?
Yeah, it was the MetaWeb. When Google required MetaWeb. Yeah. I worked on it in the knowledge graph that Google tried to create like 10 years ago. And so I'm still warming back up to them. I'm happy to see they're actually becoming popular again, but I've not drank the graph database Kool-Aid yet. I would say like when you look at like object relationship model, entity relationship model, right? That is a graph, and we are capturing that graph. There's some human that put that data into that table. They said it was an entity. That entity relates to other entities, right? We're using that structure, that level of graph, but not kind of arbitrary 3-tuple style graph database. There's some things.
I just didn't see it. That's why. I got it.
Proximity in a vector.
All right, thank you so much. This was a lot of fun. I haven't been able to give a technical talk like this in a while. Usually my talks are like 5 minutes long in like the middle of a sales demo. So I really appreciate everybody listening and asking all the good questions.